Hi, welcome to 8.2, the quadratic formula. Today we're going to start with 8.2 and then we move on to 8.3. 8.2 covers this very important formula, the quadratic formula. What is the quadratic formula? The quadratic formula is a formula that is derived from the completing the square method. Basically, the idea is that completing the square can be done using variables and constants that are arbitrary choices. For instance, if you have the equation ax squared plus bx plus c is equal to 0, this equation can be solved using completing the square, even though we don't know what a, b, and c are. And the very, very complicated solution that results, and the work for it, by the way, if you want to see the work of this, this is on page 691. If you go to page 691 in your textbook, you can see how completing the square using the generic equation ax squared plus bx plus c results in the solutions x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This solution is the quadratic formula. So the quadratic formula is simply the solution that is derived using completing the square. All the work is on page 691. And that generic formula right here, this generic quadratic equation, results in a generic solution, and since a, b, and c can represent any number, you can use this to solve any equation. So what you're going to need to do is go ahead and either write this down on a post-it note or a 3x5 card somewhere handy so that you can reference it for the duration of this lecture. I'm going to use this formula again and again and again. But make sure that you have it handy for all of your work. Okay, so first, in order to use the quadratic equation, in order to use the quadratic formula, the quadratic equation that you have for your problem must fit the form ax squared plus bx plus c equals 0. So this is what question 1 from My Open Math asks. It asks, what form do you need to have your equation in order to use the quadratic formula? And here is the answer. Once you have your equation in that form, you see it's all lined up this way. We have descending order. We have our x squared term, our x term, and our constant term equals 0. Once you have it in this form, then you need to identify a, b, and c. So you can tell right here that a is equal to negative 7, b is equal to negative 2, and c is equal to negative 4. So you don't actually have to write that out, but you need to at least think that. Once you've identified a, b, and c, then you can use the formula. So remember, you want to have the formula out in front of you at all times for this section. It's on page 691. We're going to take x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So instead of writing those letters a, b, and c, I put parentheses down. And each of these parentheses are then going to receive the values for a, b, and c. But if you write out your formula like this every time, with the parentheses, this setup right here will keep you using the correct notation, okay? So now I'm going to drop in the values for a, b, and c. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's all you have to do for question 3. You just have to be able to drop in the correct values into the correct place. For the sake of teaching you how to use the quadratic formula, though, I'm going to go ahead and continue this a little further. Okay, so this is now going to continue on as though the problem were asking you to simplify further, which question 3 on my open math does not do. So question number 3 does not tell you to simplify, but question number 7 asks you to use the quadratic formula and to go all the way to the end, giving a full simplification. In question number 7, it just has you list your answers separated by commas because you'll have both a positive version and a negative version of the answer. And it shows you also how you can type out the plus or minus in case you don't want to separate them with commas. But the idea is that you need to have a fully simplified answer. So let's go ahead and look at question number 3 here and simplify. Negative negative 2 becomes positive 2. The square root here, negative 2 squared is 4. And then we have 4 minus, oh, this is going to be a negative right here. Okay, so a 4 times 4 is 16. And 16 times 7 is, I think, 112. Hold on. So that's what the calculator's for. 112, yes, 112. So I have 4 minus 112 over negative 14. This one simplifies further into okay. Now, this book does teach what to do when you have the square root of a negative number. The book teaches you to use the imaginary number I. However, the scope of the course, this Math 105 course through UAA, does not require that I teach you what to do with the square root of a negative number. So, when you get to this point, you could say no solution. The real answer is an answer in the complex, and so you could actually say no real solution if you want to be technical. But if you just put no solution, that's fine too. Now, question number 6 has you get down as far as this. You will have a solution, and it will not be fully simplified, but you just need to be able to simplify a little further than you did in question well, you don't simplify at all in question 3, but you do simplify between question 3 and question 7. So, question 6. So, the difficulty a lot of students has is not necessarily plugging in the values right here. The plugging in part is not the harder part. The harder part is correctly simplifying. So, let's look at some simplifying techniques real quick. Okay, so question 5 from my open math has you simplify this expression. So what you want to do is simplify the square root of 720. Now you can do that off to the side, or you can do it in line in your work. If you are going to do it in line in your work, make sure that you copy the entire line. So I want to split up 720. Greatest perfect square that divides into 720. I know that 36 divides into 720, but it's also the case, since 36 times 20 is 720, that 36 times 4, which is 144, divides 5 times. Okay, so what we end up with is 144 and 5. 144 is the greatest perfect square that divides into 720. Then we simplify further. So once you've simplified the square root, then we want to deal with reducing. But we do not reduce a rational expression until we factor, remember? Okay. So here what we're doing is we are simplifying the radical. And next, we're going to want to factor. So factor before you reduce. So what we want to do is you can either factor out the GCF of 24 and 12, which is 12, or you could factor out a 4 since it's only the 4 that is going to cancel. So since I can see that the denominator is a 4 and not a 12, I am not going to actually factor out a 12 from the numerator. I'll just factor out a 4. So by factoring out a 4 from the numerator, I can cancel now with the 4 in the denominator, so that my final answer is 6 minus 3 root 5. So the purpose of this problem was just to be able to practice how to simplify a rational expression that is similar in form to the quadratic formula. Okay, so now let's look at question number 8. We have it already in the form ax squared plus bx plus c is equal to 0. So now here's the quadratic formula. Now remember, the quadratic formula starts with x equals. This is a z. So make sure when you use the quadratic formula that you pick the appropriate variable that matches your problem. So we have z equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Normally, you would be required to memorize this formula, but because of the changes for this course due to the pandemic, you get a page of notes on the test. So if you would like to include the quadratic formula on your page of notes for the test, please feel free to do so. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so a is 4, b is negative 3, c is negative 2. I'm just plugging this into the quadratic formula, and now I simplify. If you get down here and the square root of 41 does not simplify, then you don't have to go any further. Okay, so if the radical simplifies, then you simplify it. If it doesn't, you're done. And so sometimes you have a lot of simplifying work to do, and sometimes you have none. So this was a nice, simple, easy one. So here is question number 9 from my open math. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, here's the quadratic formula, and now I just drop in the letters. So remember here, a is equal to negative 2, b is equal to 9, c is equal to negative 9. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is negative 9. I have 81 minus 72. (81 minus 72 is 9. So this radical will simplify. I feel like I might have done something wrong here. Hold on. Okay, no, I didn't do anything wrong. All right, so how do you simplify this one? That's a little tricky. So what you want to do is first say negative 9 plus 3. Negative 9 plus 3 is negative 6. So that would be a negative 6 over negative 4. Negative 9 minus 3 is negative 12. So that's negative 12 over negative 4. Negative 6 over negative 4 reduces to 3/2. And negative 12 over negative 4 is positive 3. So if you end up with rational solutions, solutions that fully simplify down to rational numbers, that means the original equation actually factored. So if I go back to this original one, I can factor this, but in order to factor this, you need to first pull out the negative. And there's your factorization, and you can see then that this right here becomes a positive 3/2, and this is a positive 3, and that matches right here. Just follow the directions, though, since this whole section is about learning how to use the quadratic formula. If it says to use the quadratic formula, use the quadratic formula rather than factoring. Okay, so next I want to look at a word problem. This is page 702, number 82. I'm not going to write the whole problem up on the board, so you should look at page 702. Okay, number 82. The screen size of a television is measured diagonally from one corner to the opposite corner. This is just like the laptop screen. So there's my TV. My TV screen is, of course, a rectangle. The screen size is measured by the diagonal. Note, we would have a right triangle here because we are splitting a rectangle in half. The diagonal here, it says in 2007, Sharp developed the world's largest TV screen to date, a 108-inch flat panel liquid crystal display. 108 inches. Find the width and the height of the rectangular screen. So here's the width, here's the height. If the width were 41 inches greater than the height. So the width is the height plus 41. So I defined my variables using my diagram. The width and the height were both unknown, but then we were told that the width is 41 inches greater than the height, expressed by h plus 41. So what I want to do is not use w in my equation, just use h, so that I will only be solving for one variable. So here I'm going to use the Pythagorean theorem. A squared plus b squared is equal to c squared. So a squared plus b squared is equal to c squared. What is A? What is B? A and B are the legs. So I'll let this one be A and this one be B. It doesn't matter which. And then C is always the hypotenuse. So this becomes h squared plus, here we are squaring a binomial. Remember that when you square a binomial, you get a trinomial. H plus 41 squared is h plus 41 times h plus 41, which gives you h squared plus 82h plus 1681. And that is equal to 108 squared, which is 11,664. before you can solve using the quadratic formula, remember you need to get it into the form ax squared plus bx plus c is equal to 0. So I need to consolidate everything on one side and put it in descending order. And 1681 minus 11664 is 9983. Okay, so now I am set up to use the quadratic formula. H is equal to negative b plus or minus the square root of b squared minus 4a c all over 2a. Simplifying. Now, it says that we get to round to the nearest inch. Okay, so what we want to do is type this in the calculator and get an approximation. But let's think about this. H is height, so H must be a positive number. So negative 82 plus the square root will give you a positive number. But negative 82 minus the square root will give you a negative number. So we're going to ignore the negative number and just use the positive number. Negative 82 plus the square root, and then divide by 4. And we get approximately 50 inches. I just caught a mistake. Okay, this number right here, when I typed this in the calculator, I got the wrong number. So if you were getting a different number, you can feel relieved about that. Sorry. This is 86588. So now negative 82 plus the square root of that number divided by 4 is about 53 inches for the height, which would make the width then 94 inches. Okay, so you can even check here, 53 squared plus 94 squared. If you take the square root of that, it should approximately be 108. Yeah, you get 107.9, which would round to 108. So there you go. So that's the first word problem. Okay, so our next word problem is going to be not from the book, but from MyOpenMath. Question number 12 tells me that I have a rectangle and that the rectangle's length is 6 yards greater than the width, and that the area of the rectangle is 189 square yards, and I am supposed to figure out the length and the width, and so I can do that using the area formula. Since area is length times width, we have 189 is equal to length times width. So this would be w squared plus 6w minus 189 is equal to 0. And the question is, does 189 factor? It factors into 9 times 21. But we're not going to find two factors of 189, I'm guessing, that differ by 6. So instead we use the quadratic formula. Notice here that the a value, a, b, c, a is 1, right? This is 1w squared. So when I do here negative b plus or minus b squared minus 4ac, the a value is 1. Similarly here, 2 times a would be 2 times 1. And so this gives us negative 6 plus or minus the square root of 36 plus whatever 4 times 189 is. And that gives us 792. Now let's think about this. The width is going to need to be positive. So we're going to have the positive only. We're not going to use the negative, okay? So you can drop the negative and just stick to the positive. 792 is divisible by 4 at least. It's also divisible by 9. So 792 is divisible by 36. So negative 6 plus 6 root 22 divided by 2. So what I've done here is I've split 792 into 36 times 22. 36 root 22 becomes 6 root 22. Now I want to factor out a 2 from the numerator. This will allow me to cancel with the denominator. Now the 2's will actually cancel. So my final result for the width, I'll come back up here. The width is going to be this negative 3 plus 3 root 22 yards. And then you add 6 to get the length. So if you add 6 to that number, you have positive 3 plus 3 root 22 yards. And to check, let's get an approximation here. Negative 3 plus 3 root 22 is about 11.07. So that's about 11.07. And if you add 6 to that, you get 17.07. And if you multiply 11.07 and 17.07, you get 188.96, which rounds up to 189. So that way you can check your answer. So this is definitely not a guess and check problem, right? You have to use the quadratic formula to arrive at the correct answer. Okay, 2 more word problems and then we're done with this lecture. Okay, so here we have page 702, number 90. That's a 90. Ticket sales. A carnival usually sells 3,000 75-cent tickets on a Saturday, okay? So the usual sales for a Saturday is 3,075-cent tickets. That's the usual thing for a Saturday. For each 15% increase in price, each 15% increase in price results, well, what would happen if you increase the price? You would have fewer people wanting to buy tickets, right? If you increase the price, you're going to drop the demand. So it says that for every 15% increase in price, management estimates that 80 fewer tickets will be sold. 80 fewer tickets sold. What increase in ticket price will produce $2,982 of revenue? So the goal is to have a revenue of $2,982. What is revenue? Revenue is not profit. Revenue is how much money is coming in. It's really simple. You just take revenue is the price per item multiplied by the number of items, right? So if you have 50-cent bananas and you sell 10 of them, 50 cents times 10 is $5, so that means you bring in $5. That's not profit, that's just how much money you're bringing in. So here, we want to try to figure out the change of price, what price we should use to get to this revenue. This is the target revenue. We're going to increase the ticket price, and that's going to decrease the demand. All right, so what we have to figure out first is how many increments should we go up? How many multiples of 15 cents should we go up? Okay, so let's define a variable. N can be the number of 15-cent increases. So each time you have an increase of 15 cents, you're going to have a decrease of 80 tickets sold. So the revenue here is going to be, the price per ticket is going to be 75 cents plus n multiples of 15. Suppose I should write that the other way around, 0.15 n. Okay, so this is the multiples of 15 cents above 75 cents. And then the number of items then ends up being, instead of your usual 3,000, you're going to drop your usual 3,000 by multiples of 80. So every 15 cents your price goes up, causes the number of tickets to go down by 80. So if you increase 2 multiples of 15 cents, you drop the demand by 2 multiples of 80. And we want the revenue to equal this amount. Okay, so I need more space. So let me replace revenue then with 2,982, and I then need to copy this right here. This is 0.75 plus 0.15 n times 3,000 minus 80 n. Okay. That was a tricky setup. Now I need to get this into a form where I can actually use the quadratic formula. So that means I need to FOIL the right-hand side first. Okay, so 75 cents times 3,000. First, okay, outer and inner, let's see, 80 in times 0.75 plus 3,000 times 0.15 in is 390 n, and then 80 times 0.15 is 12 n squared. Wow, remarkably, all the decimals went away, which is very nice. And now I get everything on one side. One thing you can do to help the quadratic formula not be so complicated is to pull out a GCF, or divide both sides by the GCF. The GCF here is 6, so I'm going to go ahead and divide both sides by 6. If you divide both the left and the right by 6, this will change to 0 equals negative 2n squared. Let's see, 390 divided by 6 is 65. And 732 divided by 6 is 122. Now I can use the quadratic formula. N is equal to negative b plus or minus the square root of b squared minus 4ac ooh, wow, just drew a line right through my work. All over 2a. This simplifies to negative 65 plus or minus. Alright, let's see what this is. 65 squared plus, nope, that would be minus 8 times 122. Over negative 4. Now, in order for n to be non-negative, I have a denominator that's negative, which means I need my numerator to also be negative. So this time I'm choosing the negative because I need a negative numerator divided by a negative denominator. Ooh, actually both of them will end up being... Both of them would actually end up being used here. I'm not going to circle either one. 3249, as it turns out, is a perfect square. It's the perfect square of 57. So negative 65 plus or minus 57 over negative 4 will give me a negative 8 over negative 4, or 65... this is a negative 122 over negative 4, which results in 2, or 30.5. Okay. You do not want to increase the carnival ticket 30.5 multiples of 15 cents, because if you did, your carnival would increase from a ticket price of 75 cents each to well over $5 each. And that's way too high of a price increase. Whereas a multiple of 2 amounts to only a 30-cent increase. Okay? So a 30-cent increase, 2 represents a 30-cent increase because it's 2 multiples of 15 cents. And if you have 2 multiples of 15 cents, you end up having a carnival ticket that's $1.25, and that is more reasonable. So that's how we got to that answer. Now, if this problem is just way too overwhelming for you, this problem will help you to be able to answer number 89 in the homework from page 702. But you're not going to have a question like this on the test or on the final or even on the quiz, okay? So if you cannot handle the stress of this problem right now, don't stress about it. It's only one question in the homework you'd miss. If you are going on to higher math courses, though, I really encourage you to try to work through this problem and see if you can tackle it. This is my challenge for you. One last problem, and then we'll be done with this lecture, and then we still need to do 8.3. Okay, so here I'm looking at question number 11 from my open math. It says that the demand equation for a certain product is given right here. So here, this is the demand. P represents the unit price in dollars, and X is the number of units produced. And to figure out the revenue is simply X, the number of units produced, times P, the price, as we said in the previous problem. So we want to figure out the prices the price P, that would give us a revenue of $8,200. So we replace R with 8,200. P we replace with 134 minus 0.085x. And then you want to get this all on one side so that you can use the quadratic formula. So in this problem, your decimals do not disappear. You have an A value of negative 0.085 like that. You have a B value of 134 and a C value of 8,200. But you would then just plug this into the quadratic formula. And you can try doing that with a decimal and see what happens. And just to help you finish this, what you're going to want to do on this problem is go ahead and get all the way to an x value where you can have two x answers and you can get a decimal approximation. Take the decimal approximation of both your positive and your negative values for x, and you need to plug your answer back into the original right here. This is the price. The problem is asking you for the price, okay? The price is going to be 134 minus 0.085 times x. So take both your positive x and your negative x that you get from using the quadratic formula, plug it in here. This will give you your price, and then you will have a lowest such price and a highest such price for question 11. There is also a Get Help video right there on MyOpenMath, so you can see this problem worked out entirely. Alright, so I'm going to end the video here, and then next we'll work on 8.3.